Today we are going to see network architecture. What are the types of network architecture possible? Okay, let me continue with the session. Okay, the objective of today's session is to know about the network architecture and the types of switching techniques. And the outcome of the session is that the students may be able to understand the basic concepts of network architecture and the types of switching techniques. And these are the planned outline agenda for the today's session that we are going to deal with. So the network architecture types are layered architecture, client-server architecture, peer-to-peer architecture, and the switching techniques we are going to see. There are three types of switching techniques. The first switching technique is circuit switching technique, packet switching technique, and the third one is message switching technique. Okay, under the circuit switching technique, we are going to see there are further two types over there. One is phase division multiplexing technique, and the second one is time division multiplexing technique. So under the packet switching technique, there are two other more approaches over there. One is datagram approach, the other one is virtual circuit approach. And the last one is message switching technique and the references that we are going to deal with today's session. Okay, so the types of network which we have seen in the previous session itself, that is peer-to-peer architecture and client-server architecture. Okay, these are the two types of network architectures are available. So coming on to the peer-to-peer network architecture. So what I mean by architecture, that is layout, that is how we are going to design a particular network setup. So in that, you can go for two types of architecture. One is peer-to-peer architecture, the other one is client-server architecture. Okay, peer-to-peer in the sense, what do you mean by a peer? So it is referring any node. So node in the sense, any workstation or computers that you are connecting. Any connecting devices, the connecting devices may be a computer or a PC or any devices used for connecting the networks. For example, switch, routers, bridges, repeaters, etc. Okay. So the peer-to-peer architecture is only applicable for not more than 10 computers can be connected to form a peer-to-peer network, and there is no need for having a dedicated network administrator for controlling all the network setups or administrating the networks. So their own system. So each and individual PC or workstation is responsible for allocating the resources or maintaining some resource allotment will be done by the each and every particular computer. Okay. So each computer must have specific permissions assigned, okay, for sharing of files, and resource sharing can become a problem if the computer with the resources down. Okay, security is also a serious issue in the peer-to-peer network. So coming on to the next type, that is client-server architecture. So here you will be having a central, that is server will be maintained. So in this case, you need a network administrator to maintain all the resource allocation purpose and maintain the client system and the servers. All the work activities will be done by or administrated by the network administrator. Okay. So the server will be having a special network operating system, that is we call that as a NOS, to help providing the resources to the multiple users based on the requirement received from the each and individual users. So the client server environments usually have one or more network admin also. The problem which includes access problem and security and integrity of the data. Okay, these are the problems which come across while using the client-server architecture, and backups are needed in this environment. So the backups will be reserved in the server. So whenever there is a crash in the client system, you can go on get back your all your resources from the server. Okay, it's the main advantage of using the client server. Backups will be provided. Okay, this is a pictorial representation of peer-to-peer network. So here you can see 6 devices or 6 PCs are connected, and there is no central server will be there. Okay, no server is maintained here, and based on the request, each and every devices can send their or share their resources or data or messages to another devices. So the best example for peer-to-peer network, we can say that you can share your audio files or video files to your from one device to another device, or one mobile to another mobile, or one computer to another computer. So there you can see a peer-to-peer network formation. Okay, that's the best example for peer-to-peer network. Okay, this is a pictorial representation of client-server networking architecture. Here you can see a central server, and this server will be maintained by one or more network administrator. So they will be looking after all the resources, allocation, job, and each and every client will be connected to the server. So this based on this request provided by the client, the server will be responding to the clients by giving some response. So they can also share the files with the help of the client and server manager. It's like a master-slave like type of communication is possible. So next, let's see the difference between peer-to-peer network and the client-server network. Okay, the peer-to-peer network is very easy to set up the connection, and coming on to the client-server network, it's very difficult to set up that network. And a peer-to-peer network is very less expensive to install it, whereas client-server is more expensive to install the particular network. And the peer-to-peer network can be implemented on a wide range of operating system. In the client-server networks, a variety of operating system can be supported on the client computers, but the server needs to run an operating system that supports that networking. Okay? And peer-to-peer networks, it takes time to maintain the software being used, whereas in the client-server network, it takes less time to maintain the software being used. Okay, as the computers, as most of the maintenance is managed from the server in case of client-server. Okay, why? Because the time-consuming process is that in peer-to-peer is computers must be managed individually. So the whole system takes the responsibility of resource allocation or sharing of resources will be done by the individual computer who is using that particular computer system. So no admin in case of peer-to-peer. Okay, and coming on to the next point in peer-to-peer is very low level of security is supported here, and or otherwise there won't be any security for the data sharing also, security for your data. Okay, so this becomes the problem in using the peer-to-peer network. So that's also depending on the operating system being used. Okay, and coming on to the client-server network, you may have a high-level security is supported with the client-server network, because the data all will be preserved. If any one of the client is crashed, then you can have the backup from your server. So data will be preserved. Okay, there won't be any loss of data. Okay, such measures prevent the deletion of some essential files, system files, or changing of settings will be avoided, or it is prevented from the other users. So security is maintained in client-server network. So the next point in client peer-to-peer network is that we can go on setting up the peer-to-peer network with less than 10 computers. So with the 10 computers, we can go for making up the peer-to-peer networks. And there is no limit of number of computers can be added to create a client-server network. Okay. And then coming on to the peer-to-peer networks, it does not require any server. And it also does not require any network admin also. In case of client-server network, it requires a server running on a server operating system. Okay, so these are the points that's making a difference between peer-to-peer network and the client-server network. Okay, so this what about the network architecture point of view. Then we can move on to the types of switching techniques. So before moving on to the types, we'll see what is the use of switch and where comes the switching purpose in setting up a network. Okay, then we'll see switches plays a main role in to make the communication possible. Okay, so what I mean by a switched network. So you can see in this picture, in this more than 10 systems are connected with the help of 5 switches. Okay, so within which we can form a switched network. So switched network in the sense that you can define a series or the collection of interlinked nodes via a connecting device called switches. So with the help of switches, if you are going to make a network, that is called switched network. Okay, so what is meant by a switch? So already we have seen switch is a connecting device which is capable of creating a temporary connection between one or more devices that is linked to a switches. Okay, so some of these switches are connected to the end system, maybe a computer or a telephone, etc. So with the help of the switch, you can go for connecting the computers and telephones or any other connecting devices will be connected. So mainly switches can be responsible for the routing purpose. Okay. So this is the pictorial representation of switch. So here you can see there are 1 to n number of inputs is fed into the switch, and whereas you may get 1 to m number of outputs. Okay. Okay. So this is a pictorial representation of a network switch. Already we have seen. So what is meant by a network switch? That is, here you can at the centrally place, it's called a switch. So with the help of the switch, you can go for connecting PCs, laptops, servers, and other devices, that is webcams or scanners or printers, etc. So with the help of the switch, you can go for connecting more than number of devices. Okay. So when will we have the switching concept? So if, for example, if you are going to set up a network, so in that you need a connecting devices. So you may have a problem of having, if you are having multiple devices, how to connect or to set up a network, there comes a problem there. To make the communication possible, we have to go for the switching concept. A switch network is consisting of a series of or the collection of nodes or the collection of switches. You are going to make up a network that is called switched network. Okay, this we have seen. Okay, so now we'll have the types of switching. Okay, what are the 3 types are possible in switching? One is circuit switching, the second one is packet switching, third one is message switching. So under the circuit switching, you may have 2 types. One is space division multiplexing, the other one is time division multiplexing. So under the packet switching, you are having 2 approaches are possible. One is datagram approach, the other one is virtual circuit approach. Let's see one by one. Okay, so switching takes place at all the layers in several layers in TCP/IP protocol suite. So in the yesterday's session, we have seen two types of reference model. One is OSI model consisting of 7 layers, starting from physical layer, data link layer, network layer, transport layer, then session layer, presentation layer, and application layer. And we have also seen the functionality of each and every layers, and we have also have a comparison between OSI model and that of the TCP/IP model. So in the TCP/IP model, we have seen 4 layers, that is physical and data link layer in the OSI model is combined to have a particular layer, that is access layer or host network layer. The second layer is network layer, then transport layer, then you will be having the application layer. So all the 3 layers, presentation layer, session layer, and application layer will be of OSI model is combined to have a single application layer in TCP/IP model. So all these we have seen in yesterday's session. So now we are going to see at which layer we are going to which type of net switching technique is used at which layer. We are going to see in case of TCP/IP model. Okay, so at the physical layer in TCP/IP model, we'll be using a circuit switching technique. Okay, there is no need of exchanging the packets at the physical layer. Okay, at the physical layer, what is the type of data unit we'll be sending? So yesterday itself we have seen at each and every layer there will be a data unit representation. So at the physical layer we'll be having the transmission of bits. So physical layer will be taking the responsibility of transmitting the bits, that is in the form of zeros and ones. Okay. Okay, the switches at the physical layer will be allowing the electrical signals to pass on to from one source to destination. Okay. So at the data link layer, we'll be having the packet switching technique. So however, here at the data link layer, the data representation unit will be frames, okay, or otherwise called cells. Okay. So the packet switching is done normally using the virtual circuit approach. So under packet switching, you'll be having 2 approaches. One is datagram approach and the other one is virtual circuit approach. Okay. So at the data link layer, packet switching is possible. Okay. And coming on to the network layer of TCP/IP model, we can also have the packet switching technique. So either a virtual circuit approach or the datagram approach are used in this network layer. So if you are using internet, then datagram approach is very suitable. Okay. Okay. So at the application layer, message switching technique is possible. At the application layer, it is done by exchanging the messages. For example, you can go for sharing your mails from one person to another person. So that is nothing but it is applied by the message switching technique. Okay, it is done by exchanging the message. So such communication can be called as message switched communication. Okay, as there is no concept of message switch network is available. Okay. Okay. Let's see individual switching techniques one by one. Okay, first switching technique is circuit switched networks. It is formed by having a set of switches connected by the physical links. Okay, so a connection may be established between 2 stations, wherein which we call that as a dedicated path will be made. Okay, and however the connections, each connections will be using that only one dedicated channel on each link. Okay, so if you are having a circuit switching network, a particular link will be established. So in each link, a channel will will be dedicated to that particular, to make the communication applicable, that channel is alone allocated. Okay, so each link is divided into n number of channels using frequency division multiplexing or time division multiplexing. Okay, okay. So here in this picture we can have a pictorial representation of circuit switching. Okay, so here we may have a dedicated communication path is established between two stations. Okay, the path is a connected sequence of links between the network nodes. On each physical link, the logical channel is dedicated to a particular channel. Okay, so if you are going to have a circuit switched network, three phases has to be followed. So the first phase will be your setting up a connection. That is connection to be established. Okay. Then the next phase is to have a transmission of data. The third phase to have a disconnection or termination of the connection. Okay. So at the first connection establishment, so you'll be having the routing processes and the resources allocation will be done at the first circuit establishment phase. Then data will be transferred, then termination of the connection. So at the termination phase, all the resources that has been established for making a connection will be deallocated. Okay. So the three phases or need to communicate between the two parties in a conference hall. So making up a connection setup is the first phase, then data transfer, then connection, termination or tier down phase. Okay. So in the setup phase, it means that you are going to create a dedicated channel between the switches. So it takes time to make the connection, pre-connection establishment there. Okay, then after the connection establishment, you can go for transferring the data through a particular dedicated channel. Okay, then comes the connection termination phase, that is tear down phase. When one of the four parties or one of the system needs to disconnect, then the signal is sent to each switch to release the allocated resources. Okay, so we'll see the some of the properties of circuit switching networks. Okay, so first property is inefficiency. That is, if you're setting up a circuit switching network, then the connection has to be established. So connection establishment, you're allocating a dedicated path for the transmission to go ahead. So that transmission path will not be used by any other systems, any other users. Okay, so that comes the inefficiency of channel utilization there. Okay, if no data is transmitted, then the capacity or the bandwidth of the channel will be wasted. So there comes the inefficiency there, inefficiency of the channel. Okay, then the next property is delay. So there will be a long initial delay is occurred due to the circuit connection establishment. So it takes time to make that connection establishment in circuit switching, and the low data delay will be there. Okay, so if the channel is dedicated to a particular transmission, then there will be no case of delay in that. So the person can transmit data in an easy manner. So there is no possibility of data, or there will be some low data is possible. Okay. And the next one, circuit switching is mainly used for voice communication. So for example, we can see the public telephone network there, where you can two persons can communicate from transmission, data transmission is possible. Okay. But can also be applied to data traffic also. So here you can see a circuit switch network. So in the picture, you can see the end system A is going to transfer the data to the end system M. So the channel must be established between A to M. So you can see some 4 switches are connected. Okay. So each between the, if the A want to transfer data to the system M, then there should be a link establishment or to make the communication possible. So A will be connecting to the switch I. So it will be passing, the connection will be made in 3 phases. One is connection setup, then data transfer, then connection termination. Okay. So A will be passing the packet to the switch I with the destination address of the M. Okay. Then I will be looking for the next path establishment is to the from 1 to switch 4. Then from switch 4, it will be making the connection establishment with the switch 3. Then switch 3 will be making the connection with the destination system M. Okay. So A will be transferring the data with the destination address. Okay. Okay. So here each link is divided into 3 channels. That channel will be channel division will be done by the time division multiplexing or frequency division multiplexing. Okay, here you are having 2 end system. One is A and the other one is M. The end system may be the computers. Okay, so A has to transmit to M. That will be done through the circuit switched network. Okay. The explanation is given here. So what is the advantage of using circuit switching technique is that the communication channel is a dedicated one. Channel is only with that dedicated channel, the data can be transferred. So there won't be any delay in communication or delay in transmission of data. Okay. So coming on to the disadvantages in circuit switching, you may face a long wait to establish a connection. So that we have seen switching network, if you want to make a switching network, circuit switching network, you'll be have to follow 3 phases. So the connection setup, then data transfer, then connection termination. So for connecting the setup phase, it makes, there will be a delay in setting up the connection. Okay. So during which no data can be transmitted. So it is more expensive than any other switching techniques, then because the dedicated path is required for each and every connections. Okay. So the next disadvantage is inefficient use of the communication channel. That is, you can have no other users or no other system can transmit any data while there is a dedicated path is allocated for the 2 end systems. Okay. So the other person has to wait until the dedicated channel capacity is deallocated to the other users. Yeah. Okay, circuit switching is used in public telephone network, but it is used for data transmission as also along with the voice communication. So voice communication is very efficient in circuit switching technique, but data communication is not up to that efficient. Okay, in this method, a dedicated path is established between the 2 computers using 1 or more switches. Okay. So mainly the circuit switching technique will be established, or you can make that type of technique at the physical layer in the TCP/IP model. And the data transfer may use the frequency division multiplexing or time division multiplexing. Okay. Okay. So this is an example for circuit switching network. You can have a PSTN, that is public standard telephone network. Here you can see a telephone which is acting as a subscriber. That subscriber is having the connection with the end office. Okay, subscriber or nothing but the device that attaches to the network. So what do you mean by subscriber loop is that you can link the subscriber and the network. That is called a subscriber loop. Okay. Then exchanges means the switching centers in the network. We call that as the exchanges, and end offices or switching centers that directly connected to the subscribers, okay, or directly supports the subscribers or the end offices. Then trunk is nothing but the branches between the exchanges. So these are all the large block, we call that as the exchanges, and the small block we call it as the end office. Okay. So what are the certain problems in circuit switching is low efficiency, because some of the resources will be remain dedicated throughout the connection. So that will face some low efficiency of channel utilization. That's the main problem in circuit switching. And there will be no delay. That is the lower, despite of low efficiency, there is very low delay in the transmission also. Since the connection is dedicated to, so only time taken in the connection is the only delay in the transmission. Okay. So this is how the delay occurs in a circuit switched network is picturized here. So A is going to communicate with the B through the two switches, and here you can see the connection is established. So only delay you can have, that is to set up the connection, you may have a delay there, and at the termination of the connection you can have the delay there. Okay, so we call that as a total delay. So advantages, dedicated transmission is possible. There won't be no delay in the transmission of data. Disadvantages, that is because of dedicated connection, no other device can, no other devices wasting their time in waiting, since the channel is occupied or allotted for the two end systems. Okay, the dedicated connections will consume all the bandwidth. No sharing of bandwidth is possible with this circuit switching. So there is a waiting time is more here. Sometimes it may take long time to establish a connections also. Okay, so major application where we can apply the switching technique is a public switched telephone network. It is PSTN. Okay, next we'll move on to the types of circuit switching. Already we have said there are two types in circuit switching. One is space division switching. The other one is time division switching. Okay. So space division switching. In the space division switching, the paths that is maintained in the circuit switching will be separated from each other path spatially. The thing is that the path will be separated from each other path in some particular distance. Okay. This technology is used in both analog networks also and also in digital networks also. It uses the following switches for connection. There are two switches used for making up the space division switching network. One is the crossbar switch and the other one is the multi-stage switch. Okay. We'll see the pictorial representation of the crossbar switch. Here you may see the grid-like appearance. So each and every input and on output will be, it makes a cross point at the meeting point. Okay. So the crossbar switch will be connecting n number of input lines to m number of output lines in a grid using the micro switches. So micro switches, you can say for example, transistors. So at each cross points, we'll be having a transistors to control the stations. So the second type is multi-stage switch. So multi-stage switch is that can make possible this with the help of the crossbar switches at each and every stages. So stage 1, there are more number of crossbar switches used. In this picture, you can see 3 stages are possible. You can make more number of stages also with the help of the crossbar switch. Okay, the limitation of the crossbar switch is removed by the multi-stage switch. Here, it combines the crossbar switches in several stages. Okay. In multi-stage switching, the devices are linked to switches that, in turn, they are linked to a hierarchy of the other switches. Okay. So multi-stage switching, for example, 13 is connected to the second system. 13 system is connected to the second system using the multi-stage switch. Okay. And another example, 4 is connected to the 9. Okay. So there are some of the examples of circuit switched network that is already we have seen. Public switched telephone network and ISDN channel. Then in GSM, you may have a circuit switched data, that is CSD, and high-speed circuit switched data, HSCSD services. In cellular systems such as GSM, you may have a circuit switched network, and in data kit also you can have the circuit switched network, and X.25 protocol you can have the circuit switched network. Now, optical mesh network also you can have the circuit switched network type of techniques there. Okay. Then comes the second type in circuit switching is time division multiplexed switch. So in this case, a specific time slot is allotted for each and every channel. Okay. For each and every users, a specific time is allotted. Okay. To making up the transmission in a smooth manner, time slots are allotted for each and every users to make up the transmission in a better way. So these types of time division multiplex switches are used in voice calling. Okay. The next type switching technique is message switching. So far we have seen circuit switching technique. In that we have seen the classification is 2 types. One is time division multiplexing. The other one is space division multiplexing. So under the space division, you can go for setting up the space division network using crossbar switch and the multi-stage switch. Okay. Next we have seen time division. Next one is message switching technique. Okay, with the message switching technique, you can utilize this type of switching in the application layer of the TCP/IP model. So there is no need to establish a dedicated path between the 2 stations. Sorry. When a station sends a message, the destination address is added onto the message. The message is then transmitted through the network in its entirety from one node to another node. Each node receives the entire message and it stores the message whenever it reaches the switches or anything else. The data will be stored on a disk and then it transmits the message to the next node. So this is what the procedure followed in message switching technique. So what is the major concept is carried out is that store and forward network. This type of network we call that as a store and forward network. So the thing is that whatever the data packets receiving in a particular switch or any end system, it will store the particular packet and then it waits for some time, or it is being buffered there. After that, it goes on, it selects the routing path based on from the routing table. The routing decision will be done. Then it will forward the packets to the corresponding route to reach the destination. So this was the concept in message switching technique. We call that as a store and forward technique approach. Okay. So here you can see the message switching technique from A to H. The messages, two messages are passed. Okay. So a message switching node is general purpose computer. Okay. So here each node is representing the computer, and the device needs sufficient secondary storage device capacity to store the incoming messages. Okay, which could be a very long time to store there. Okay, a time delay is introduced using this type of scheme due to the store and forward time. Okay, plus the time required to find the next node in the transmission path. So there comes the delay here. Okay. Whenever the packet receives any node, it will be stored and buffered there, and it takes some time for the routing decision to be carried out. Okay. That's the delay in store and forward approach. Okay. So what is the advantages of a message switching technique? The channel efficiency will be greater when compared to the circuit switching technique because more devices are sharing their channel. That's the main point to be noted here. In case circuit switching, the channel will be dedicated to a particular transmission. Whether if the user is not going to transfer the data or it is kept nothing, that is no transfer of data is carried out, the channel will be dedicated to only that for that transmission alone. So that's the not the case in message switching. Okay. The traffic congestion can be reduced because messages may be temporarily stored en route. Okay. The messages will be assign some priorities, that can be assigned some priority. So whichever the messages having the higher priority, they can be passed or forwarded to the destination in a faster manner. Okay, that's the thing is possible in message switching technique. Okay, so message broadcasting can also be achieved with the help of with the use of the broadcast address that is added or appended with the message. Coming on to the disadvantages of message switching, it is not compatible with some of the interactive applications. Okay? So store and forward devices are very expensive. So there is a need for storing and forward process. We need to have a secondary storage devices. So that makes expensive here. Okay? That's the disadvantages of message switching because they must have large disk to hold long messages. Okay. So next comes the third technique, that is packet switching technique. Okay. So this packet switching technique may be the solution for the disadvantages that we have faced in circuit switching as well as the message switching. Okay. So all the advantages of circuit switching and advantages of packet message switching are combined to have in this packet switching technique. Okay. So in this case, we are going to see two methods or two approaches in packet switching. One is datagram approach, the other one is virtual circuit approach. Okay. So here in this picture, you can have a packet switching, how the packets are transmitted from A to H. The source is A and the H is the destination system. So normally, whenever the data is transmitted from one node to another, in case of packet switching, the data will be divided into number of packets. Okay? So the messages will be divided into number of packets. So each and every packets will be forwarded to the next node, and but the source system will be, it has the destination address in its message. Okay, so based on the destination address, it will pass on to every other nodes, and every messages or every packets will be forwarded to the destination. So after reaching the destination, all the packets of the particular message will be reordered, and H will be sending the acknowledgement to the source. Okay. So coming on to the concept of packet switched network, the messages are divided into n number of packets. So this size of the packets will be determined by the network's ORLs and the governing protocol. So no other resource reservation, but allocated on demand. The resource in the sense, a path will be established, the channel allocation will be done based on the demand. So it is done based on the first come first serve based. Okay. So whoever want to transfer the packet, they will be served first. Okay. When a switch receives a packet, the packet must wait if there are other packets being processed at the switch. Okay. This lack of reservation may create a delay. Okay. So next comes the datagram approach. Okay. Datagram approach in packet switching is similar to the message switching in that each packet is self-contained unit with the complete addressing information is attached. Okay, the destination address will be attached to the packet. Okay, this fact allows the packet to a variety of possible paths to the network. Okay, so the source system will be forwarding the packets. It will pass on to number of systems in between. So the message is divided into number of packets. That packets will be following many routes, and finally it reaches the destination. So at the destination, reordering of the packets will be done. Okay. So this fact allows the packets to a variety of possible paths through the networks. So the packets, each with the same destination address, do not follow the same route. Okay. They will be following some other routes to reach the destination, and they may arrive out of sequence at the exit point node. At the destination, they will be following some sequencing the packets. Okay. So reordering is also done at the destination point based on the sequence number of the packets. So each and every packets will be assigned some sequence number. Based on the sequence number, reordering will be done at the destination of the destination point. Okay. It is possible for a packet to be destroyed if one of the nodes on its way is crashed. Okay, then all the queued packets at the node will be lost. So that's the main disadvantage of using the datagram. Okay, if any intermediate node is crashed, then the packet reaching that particular node will be lost or dropped off. Okay. Okay, this is a pictorial representation of the how the datagram networks works. Okay, so here in this approach, the packet is represented by a term called datagram. So it is treated independently of the all others. Okay, all the packets, or otherwise called as datagrams, they belong to the same message. So for example, system A is going to communicate with the system X. So it is going to transfer the datagrams. So initially the datagrams are segregated into 4 packets. Okay, it will be reaching. So it will be following the routes through the routers or switches, and finally it reaches the destination. At the destination, it will be following the reordering of the packets will be done based on the sequence number assigned to the each and every packets. Okay. So this datagram switching is carried out at the network layer. Okay. So this approach can cause the datagrams of the transmission to arrive at the destination out of order with different delays between the packets. Okay. So the first packet might have arrived first. So suppose if the message comprises of 4 packets, Might be we are in search of third packet to reach at the destination. It may have some delay. So after reaching, you can go for reordering at the destination point. Okay. The packet may also lost or drop because of lack of resources. In most protocol, it is the responsibility of an upper layer protocol to reorder the datagrams or ask for the lost datagram before passing on to the next highest level, that is application layer. Okay. The datagram networks all is performed or referred to as connectionless networks. There will be no setting up the connections or initially, as in case of circuit switching, there will be no initial connection setup in case of datagram networks. Okay. So how the packets are forwarded to the destinations. So how the data is transmitted from source to destination. So each and it has to pass some intermediate nodes, that is devices, that is via the switches or routers. The source will be transmitting the data to the destination. So each router will be maintaining a routing table. So routing table, it comprises some destination address and the output port. So source will be mentioning the destination address in its message or in its packet that will be stored in the routing table. So whenever the data packets arriving at the router, it will dynamically update the routing informations in the routing table. Okay, so the updation is only with that of the output port and not with the destination address. So source node will be mentioning the destination address. So that will be remaining the same in each and every router routing table. Okay, only there will be a difference or updation in your output port information. Okay, so destination address in the header of the packet, the datagram network remains the same during the entire journey of the packet. Okay, that's the thing we have to make a note of it in a datagram approach. Okay, so what is the efficiency of the datagram approach? It is better than the circuit switched network. Okay, the resources are allocated only when there are packets to be transferred. Okay, so channel utilization is properly maintained in the datagram approach. If a source sends a packet and there is a delay of few minutes before another packet can be sent, the resources can be reallocated during these minutes for the other packets from the other sources to carry out the communication or the transmission. So that's the main advantage here. Switching in the internet is done by using the datagram approach. So in internet, you are following the datagram approach to packet switching at the network layer. So the delay is here represented in datagram network is that, suppose if A is want to transmit to the B, it has to pass through two routers. Okay, so each and every routers will be maintaining the routing table, wherein which it will be following the destination address as well as the port numbers. So the port numbers, there is the output port through which the packets to be forwarded to the next node. Okay, so at that time the routing decision will be done by the router. So it takes some time for the packets to wait till the routing decision completes there. Okay, so at whenever the packet reaches the router, it has to decide to which route to be forward the following packets. So there will be a waiting time at each and every routers. Okay, so we can calculate the total delay as 3 capital T plus 3 small t plus W1 plus W2. So here capital T is representing the transmission time and small t is representing the propagation delay in transmission, and W1 and W2, the addition of 2 is nothing but the waiting times. Waiting time for the routing decision to be carried out by the router. Okay. Next, the second type in packet switching is virtual circuit approach. So in virtual circuit approach, a pre-planned route is established before any data transmissions to be happened here or data transmission to be sent. So which is likely similar to that of the circuit switching. So circuit switching technique, you have to follow 3 phases. One is connection setup, data transfer, and the next one is connection termination. So here in virtual circuit, you have to have a pre-planned route. Okay. Okay. The logical connection is established when a sender send a call request packet to the receiver, and the receiver send back an acknowledgement packet through call accepted packet to the sender. The receiver agrees on conversational parameters. What do you mean by conversational parameters is that it can be a size of the packet, maximum size of the packet size, and the path to be taken, other variables are necessary to establish and maintain the conversation. Okay. The virtual circuit implies the acknowledgements, flow control, and error control. So we call, if you follow or apply this virtual circuit, it will be a reliable transmission of data. You can have the reliable transmission of data. That is, the user can make use of this virtual circuit. Then they can ensure that the transmission is done in a reliable manner. There won't be loss of data, okay, because the pre-planned route is established before the data are transmitted. Okay. That is, they have the capability to inform the upper protocol layers if a transmission problem occurs. Whenever the problem occurs in the channel or any disruption occurs, it has to inform the upper protocol layers. So in virtual circuit, the route between the stations doesn't mean that it's a dedicated path as similar to that of the circuit switching network. Okay, it's a virtual circuit is established between the source and the destination. That is, a pre-planned route is dedicated or established. Okay, so a packet is still buffered at each node and queued for output over a line. The difference between virtual circuit and datagram approach is that with the virtual circuit, the node does not need to make a routing decision for each and every packet. As we have already seen in the datagram approach, so whenever the data packet arrives at the router, it has to wait till the routing decision happens in a fast manner. Then it has to forward the packets to the another node. So there are waiting time or delay in that particular time. So that's not the case in virtual circuit approach. So pre-planned route is established, so we can go for transmitting the data in a fast manner when compared to that of the circuit switched. Okay. When compared to that of the datagram approach. Okay. So this virtual circuit approach guarantees the packet sent arrive in the order sent. Okay. So in which order the packets are sent, we can reorder at the destination. So here you can avoid the duplicates of packets. It's not possible here, and we can also avoid the errors with high probability regardless of how they are implemented internally. Okay. So here you can have the pictorial representation of the virtual circuit network, how it works. So it's a cross between a circuit switched network and the datagram approach. The characteristics, it has the characteristics of both the circuit switched network and the datagram network. So what are the characteristics? That is that the packets from a single message travel along the same path. Okay, so routing decision will be already taken whenever the connection is established between the source and the destination. So there won't be any delay of transmitting the data. So three phases has to be maintained to transfer the data. One is setting the connection, data transfer, and termination, that is tear down the connection, which is similar to that of the circuit switching network. Circuit switching, you will be having a dedicated path will be established, but this is not the case. Pre-planned route will be established. No waiting, no propagation delay for the routing decision to be carried out. So you can go ahead with transmission of data in a faster manner. Okay. So the resources can be allocated during the setup phase itself. Okay. The data will be divided into packets, and each packet will be carrying the address in the header. Okay. And this kind of virtual circuit network is implemented in the data link layer, whereas Datagram approach will be implemented in the network layer. Okay. So in virtual circuit network addressing, you can see two types of addressing. One is local addressing, the other one is global addressing. So what is meant by local addressing? Whenever the packets receiving at each and every node, or there will be a creation of virtual circuit identifier, which is called as VCI. Okay, that we call it as a local address. Okay. What is meant by global address in the sense source address and the destination address needs that address needs to be a unique one, which is used by the switches only to create, with the help of the source address and destination address, it will be creating a virtual circuit identifier during the connection setup phase. Okay. So this actually local addressing will be used for data transfer, that is VCI, and a small address, which is VCI is a small address used by the frame between the two switches. Okay. So here you can see the picturized representation of routing table, maintaining the incoming and the outgoing details. So in the incoming, you may have the port details, incoming port, and the virtual circuit identifier. And in the outgoing side, what is the outgoing port to be used, and virtual circuit in identifier. So all will be mentioned in the routing table. So here, see the data having the packet 77 and 14 is coming on to the switch. Okay, so through the incoming port 1, and VCA is the virtual circuit identifier is 14. Then the output port is 3 is mentioned here, and the VCA is 22. Okay. So this is what the routing table maintained in case of virtual circuit network. So similar to the virtual circuit approach, will be following the circuit switching network, that is setting up a connection, then data transfer, then disconnection of the termination of the connection. Okay. So how their virtual circuit is setting up a request. So here A is going to communicate with the B. So it is passing via 3 switches, switch 1, 2 and 3. So each switch will be maintaining some information about the incoming port and the outgoing port along with the VCA. Okay. So here A, B, C, D are the packets to be transmitted from one node to another node. Okay. So at the switch 1, the incoming port is 1 and the outgoing port is 3. And here the VCA is 14, that is the data to be passed. Okay. And okay, at the switch 2, the incoming port is 1 and the outgoing port is 2. With the VCA, B is having the message 66. Okay. And then switch 3. So while setting up the request, there won't be any outgoing, there won't be any information at the outgoing VCA. So after setting up the request and data transfer, then see here, So setting up the acknowledgement after the data received at the destination B. So you can know the outgoing VCA that will be filled in each and every routing table at the outgoing VCA. The information will be filled. So before data transfer, it is nothing but setting up the connection request. So you won't be aware of the VCA, outgoing VCA in each and every table. Okay. So when the destination B receives of the frame, it is ready to receive the frames from A, and it assigns the virtual circuit identifier, in this case 77. So this VCA lets the destination know that the frames comes from the source node A and not from the other sources. So B destination will be making note of it that only the data coming from the source, that is the end system, A is going to, A has sent the information to B. Okay. So then data transfer happens, and at last, after the connections, data transfer is over, then there will be a termination of the connection. So after sending all the frames, a special frame is sent to the end of the connection. So the destination B will be responding with the tear down, there is termination confirmation frame. So after the confirmation, it will the termination of the connection will be carried out. So there is a delay in virtual circuit switching. In Datagram network, each packet may experience a wait at the switch before it is forwarded to the next node because of the routing decision to be happen. Okay. In addition, the delay is not uniform for packets of the message. So this is what happens in Datagram approach. In case of virtual circuit network, there is one-time delay for setting up the connection. Here you can see this, for setting up the connection, it may take time. And one-time delay while the connection after the data transmission, you can go for terminating the connection. There you can have the delay, which is similar to that of the circuit switching. Okay. So if resources are allocated during the setup phase, if there is no resources are allocated, then it can move on to the next person to occupy that particular channel. Okay. So what is the advantage of using the packet switching network is that it is more cost effective because the switching devices does not need any of the secondary storage devices. Okay, the packet switching offers improved delay characteristics also because there is no long messages in the queue. So maximum packet size will be fixed by the network. Okay. So there is no need for storing the long messages. There is no need for secondary storage devices also. So no delay. So packet can be rerouted if there is any problem occurs, such as if the link is very busy, the channel is busy, then it can be rerouted. It can find the next alternative path to forward the packets. That is possible in packet switching. The advantage of packet switching is that many network users can share the same channel at the same time. So that's the main point to be noted in or main advantage in using the packet switching network. So in case of circuit switching, the channel utilization is very poor since that channel is dedicated only for that particular transmission to go ahead. But in case of packet switching, the channel is shared by many number of users or end systems to make the communication possible in a fast manner. So packet switching can maximize the link efficiency by making the optimal use of the link bandwidth also. So what is the disadvantages of packet switching? The protocols used for packet switching are very complex, and it can add some initial cost in implementation part. If the packet is lost, the sender needs to retransmits the data. That's the disadvantage case of packet switching. Another disadvantage is that the packet switched system still can't deliver the same quality as the dedicated circuits in applications requiring very delay, like voice conversations or moving images. So there's some delay. Okay. Quality will be. So on comparing the datagram approach and virtual circuit approach, there will be no call setup phase in datagram approach, whereas in virtual circuit the network can provide some sequencing the packets, and error control will be done in this virtual circuit. And datagram is more flexible, transmission is possible, and in the datagram approach, it's better approach if number of packets are not very large. So if the size of the packet is very low, then we can go for using the datagram approach for better transmission of data. Okay. So in coming on to the virtual circuits, the packets are forwarded in a quick manner because so it has set up the routing in a routing decision is taken at the prior stage. Okay, so there won't be delay. The packets will be forwarded in a quick manner. So less reliability in virtual circuit. Okay. So in the previous slide, we have seen the comparison between two types of packet switching, that is datagram approach and the virtual circuit approach. Here we are going to have the difference between packet switching and circuit switching. So mainly circuit switching is designed for voice communication, and packet switching is mainly designed for the data transmission. Okay, and the packets will be containing the user as well as the control information. Control information is nothing but the routing address informations. Okay, user data may be the part of the larger message. The packets are received and they can be stored and buffered and passed on to the next node. That's in case of packet switching. So we call packet switching technique as a store and forward approach. Okay, that's we can have the comparison. In case of circuit switch network, we can have a dedicated transmission path with the help of the copper wire, and there is no dedicated path in packet switched, and the bandwidth available for in case of circuit switched is a fixed one, that is the channel allocated throughout the transmission data. It won't be shared by any other users. So the bandwidth available is fixed in circuit switch. It is dynamic in packet switched. So based on the requirement of the resource to be transmitted, the channel will be allocated based on the requirement. So the channel will be shared in case of packet switched networking. Okay. So coming on to the potentially wasted bandwidth, in case of circuit switching, the channel might go for utilization can be wasted, but this is not the case in packet switched network. Okay, and coming on to the item, that is store and forward transmission is not possible in circuit switch, and it's possible in the packet switch. Okay, each packet follows the same route. In case of circuit switch, there is no other route to be followed in circuit switch. But in case of packet switching, if there is any packet loss, then the router can decide the different path to forward the packets to reach the destination. Okay. So call setup is required in circuit switch, and there is no call setup in packet switched. Okay. And when can congestion occur? In case of circuit switch, at the setuping time of connection, congestion may occur. But in case of packet switch, on every packet transmission, congestion may occur at every node or at the every connecting devices, congestion may occur. So charging of circuit switch network is per minute, and charging of packet switch network per packet. Okay, so there are 5 protocols call these 5 protocols are used for the services to the packet switching technique. X.25 protocol, ATM, that is asynchronous transfer mode protocol, then frame relay, then switched multi-megabyte data service, and the last one is Ethernet or IP packet networks. So these are the 5 protocols in use for the packet switched services, which will be providing, these protocols will be providing the packet switch services. So these are the references used for making the presentations. So thus we have come to the conclusion of the third day. So in this, let me summarize what we have come across in this session. So we have seen layered 2 types of network architectures. One is the client-server architecture, and the other one is a peer-to-peer network. Then we have seen some examples regarding the 2 networks. Then we have seen the switching techniques clustered into 3 types. One is circuit switching technique, and the other one is packet switching technique and message switching technique. So circuit switching is carried out at the physical layer of the TCP/IP model. Packet switching is carried out at the network layer and data link layer also. Datagram approach is carried out at the network layer, and virtual circuit is carried out at the data link layer. And message switching technique is carried out at the application layer of the TCP/IP model. So we have seen 2 types of circuit switching. One is space division multiplexing, and the other one is time division multiplexing. So with the 2 types of switches, space division multiplexing is carried out. One is crossbar switch and the other one is multistage switch. And the next technique we have seen packet switching. In that there are 2 approaches over there. One is datagram approach, the other one is virtual circuit approach. And we have seen how the process is going on in each and every switching networks, and what are the advantages we have seen, what are the disadvantages we have seen, and we have seen the comparison between each and every switching techniques. Thank you students for patient listening.